right, guys, when it comes to graphing systems, first thing that we got to understand, let me go over the inspirational quote first. I love it. It's one of my favorites. It comes from the great Michael Jordan. I can accept failing. Everybody fails. What I cannot accept is not getting up and trying again. Just a great, great quote. A lot of you guys are always so afraid of failing, but you're going to fail in life. And the most important thing is learning from those mistakes and getting back up. So, all right, we're going to jump in and talk about graphing systems. Understand what a system is. System is real simple. Instead of one problem or one equation in a problem, we are now going to have two equations in one problem. So these suck because it's pretty much double the work for one problem. Um, and so that's what makes this a little bit more complicated is now we're just doing more work and everybody hates to do more work. But when it comes to systems, remember, understand that since I have two equations in one problem, I need to find the solution that works for both equations. I can't find one solution for one and then one for the other. I have to find a solution that will make both of them true. So that's what we're working on. Okay? So once again, systems has two equations and one problem. Our solution, guys, to this is when we're talking about graphing. So the first way we're going to teach this is by graphing, and then we'll move on to the other methods. Okay, but the first method is by graphing. So what we're going to do is we're going to graph systems. So what we're going to do is we're going to graph both equations, and what we're looking for is where they intersect. That point that lies on both lines. So remember, when we graph an equation, it is the list of all solutions. Okay, so that's what we're really focusing on. Is it's not a line. It is the every solution to that one problem. All right. And so that hopefully will start making sense because we have three different types of solutions to a system. The obvious one, the one that's probably going to be 90% of the time, is going to be our one solution. All right. And how do I know it's a one solution? Well, we know that they're going to cross at one point. Okay. So if my two lines cross at one point, that is the solution. I have one solution. Remember, trying to get you guys to understand this, that this isn't really a line. This right here, this line is made up of infinite amount of solutions to this one problem. Okay, so whatever this problem is, and we'll show you that when we get down here. Okay, but when we're looking at this, remember this line is actually made up of infinite amount of points. And to the naked eye, because there's so many, to the naked eye, it looks like a straight line, but it's really not. Okay, it's really infinite amount of points, and every one of these points is a solution to the blue problem. All right, and then it's obviously going to be the same thing that this red line or orange line is going to have infinite amount of points, and these points are going to be the solution to the red problem. Okay, so now what we got to understand is, well, I'm looking for a solution that makes them both true. So when you think about that, I am looking for a solution that has to be in both equations. And the only solution that is in both equations would be this point located right there in the middle. All right. And when I find that point, then what I do is I write out the solution, and it's real simple. All solutions are going to be written in the form x comma y. So whatever x equals, whatever y equals. Okay, and remember, x goes left and right. That's my x-axis, and the y is the up or down. All right, so we're always going to start at the origin. So I'm going to start right here at the origin, and I got to figure out how do I get to that point. Well, I go left or right how many times? Well, I don't go left or right at all. So I don't go left or right at all. So then that's going to be 0. And then how many times do I go up? Oh, I go up 1. So my solution to this problem is 0, comma 1. So what I'm saying is, hey, if I plug in 0 for x and I plug in 1 for y, then that should make both of those equations true. All right. And that is the only solution that makes them both true. All right. That's why we have one solution. So now we jump in. We have two other forms. We have what is known as a no solution, okay, and an infinite solution. Well, the no solution is really simple. All right, it's pretty simple. In order for it to have no solutions, my lines can never cross ever, and the only way that they can never cross is if the lines are parallel. All right, and remember the most important thing about parallel lines that we care about when we're graphing is they have the same slope. So if we end up having two lines that have the same slope, then we should realize that they are going to be parallel. So then that means that we have no solutions. And once again, that's pretty easy to understand why there's no solutions, because my solution is where they cross. And if those lines never cross, then I'll never have a solution. So the answer here would be no solution. Okay. And then the infinitely many solutions, really what happens is with infinitely many solutions or all solutions is when the lines are the same. So, right, I got this yellow line and I have the black line, and they end up being on top of each other. So, why is it infinitely many solutions? Well, we're looking at where they cross, and technically each line is made up of infinite amount of points. And where do they cross at? Well, they cross at every single point because it's the same problem. All right. So it doesn't really matter what point I pick, it's going to be a solution to that. So I have infinite amount of solutions. That only happens if they end up being the same line. Okay. If they end up being on top of each other. All right. So that's pretty much all you really need to know. Everything else comes from the previous knowledge of graphing. So let's jump in. I'm going to do a couple of examples real quick, real fast, so you guys can see it. Okay. I'm going to graph them. I have three examples here, and then we'll move on and we'll be done. So taking a look here, if I'm going to graph this, the first thing that I want to do is make sure that the y is by itself. The y is by itself here. So now this makes this pretty simple. Remember, m is going to be, right, this is in the form y equals mx plus b. M is the number in front of x, b is the number by itself. So this equation is going to be m equals 2. Make sure we turn it into a fraction. And then the b value here is going to be 4. So I'm going to graph this. I'm going to do this one in blue. So remember, I'm going to begin. Where I begin is always up or down. So I'm going to begin at 4. So that tells me to go up since it's positive. So I'm going to go up 1, 2, 3, 4. I'm going to put my dot right there. And then with the slope, I'm going to go up 2 over 1 because it's positive and I always go to the right. So I'm going to go up 2 over 1, put a dot. Now, I will be honest, when I graph systems, this is the only time I do systems, is I'll make sure that I go a couple more times just because you'll see it makes life a little bit easier down the road. So I will go up 2, so up 2 over 1. If you run out of graph, just add it. Okay, and then I know most of you guys will get this, but understand that instead of going up to it and to the right one, I can go backwards or work opposite to get stuff. So instead of going up 2, I'm now going to go down 2 and to the left. Okay, and that should still be on the same line. So I'm going to go down 2 over 1, down 2 over 1. And the only reason I do this is you'll see it'll make life a little bit easier, especially if you don't have graph paper. You'll see it'll make life a lot easier. Okay, so now let's graph. I'm going to do the other one in green. Once again, we just got to find m and b. This one's pretty simple because the y is by itself. So m is going to be 4. Make sure that we put this as a fraction because m is always a number in front of x. B is always a number by itself. So I'm going to begin up to. Remember, the B has that tail, so it tells me to begin up to. And then I'm going to go up 4 over 1. So remember, I always begin at B, and then I do the movement. So I'm moving up 4, 1, 2, 3, 4 over 1. And boom, right away, we should notice that that point right there is going to be the solution to my problem, okay, because that is the point that is on both of them. All right, and so now I need to write out the solution. Remember, the solution is always written x comma y. I got to figure out what x is, and I got to figure out y. Remember, x is always left or right from the origin, and y is always up or down. Don't mix them up. Don't do the slope. A lot of people do that. So I'm going to start here at the origin, and I got to get to this point right here. That's the solution. So how do I do that? Well, I know I got to go over 1. So x is going to be 1, and then I go up 1, 2, 3, 4, 5, and 6. So now the solution to this problem is 1 comma 6. I'm only going to do it on this one, but we can now take these and plug these in to see if we did it correctly. So this is x, this is y. So I'm going to replace the blue one, and it's going to be 6 equals 2 times 1 plus 4. If I simplify this, I get 2 plus 4. 2 plus 4 is 6. So this right here, this solution makes this one true. Now I need to make sure it makes this one true. So I'm just going to plug it in once again, plugging in 6 for y, 1 for x, and I'm going to get 6 equals 4 times 1 plus 2. And I'm going to solve. 4 times 1 is 4, plus 2 is 6. So I do end up having the solution that makes them both true. So I know that is my solution. Okay, so I'm only going to do it on that one just to save a little bit of time. Okay, now let's graph these real quick. So I'm going to graph this. Remember this one right here. We'll do it in blue. This one's that funky one. It's not too hard if you can just understand there is no y here, so I can't graph it using y equals mx plus b. But I do know, hey, since there's no y, this means I cannot cross the y-axis. So I can figure out where x, here's x. Where does x equals 4 at? Oh, there's x equals 4. And now I know that this line can never cross this line because there is no x here. So we're going to make it parallel. And so this is x equals 4, the blue line. Okay, and then I'm going to graph the other one. I'm going to graph that one in green. Remember, the number in front of x, as long as the y is by itself, is going to be the slope. And then the number by itself is the b value, the y-intercept. So I'm going to begin here at 3, because that's where it tells me. So I'm going to begin up 1, 2, 3, put my dot. And then I'm going to go up 1 over 1, 2, 3, 4. And you can see right away, boom, I like it. It's pretty simple. That point right there is my solution. How do I get to that point? Remember, it's always x comma y. So x goes left or right, y goes up or down, starting at the origin. So I go 1, 2, 3, 4 to the right, and I go up 1, 2, 3, 4. So the solution to this system is 4 comma 4. If I were to plug it in, I would know that it would be correct. Okay. Now, taking a look at these problems right here, this is where they kind of start getting a little troublesome, just because we notice that this is not in the form y equals mx plus b. So what I have to do is put it into the form, because that's the easiest way to graph. So what I'm going to do is I'm going to take the first one. Let's do that one in blue. So I'm going to go x plus y equals -2. Okay, and what I'm going to do first is I'm going to solve for y. Why do I solve for y? Well, because if you notice in y equals mx plus b, we want the y by itself. So I just need to get rid of the y. So I need to get rid of the x. Remember, it's not multiplying, I'm adding x. So to get rid of this x, I'm going to subtract x to both sides. When in doubt, you can always put a 1 in front of the variable if you want. And this will give me y equals -1x minus 2. Now it is in the form y equals mx plus b, so this is m. M is -1. Put that as a fraction. And then b is always a number by itself, which is 2. So now I'm going to begin up 2, put my dot, and then this tells me to go down 1, over 1, down 1, over 1, down 1, over 1. Remember, I'm going to do a couple of dots just to make sure that it makes life easier, especially since you can tell that my line's not straight. That's where you guys are going to have problems down the road, is if you don't have a straight line, but we'll be okay here for this. Now I'm going to do the exact same thing here. I'm going to solve for y. So I'm going to subtract. I'm going to put that 1 in front. So I'm going to subtract that 1x. These cancel out. I'm now left with y equals -1x minus 1. Oh, right here. Now it's in the form y equals mx plus b, because y is by itself. So this is m and this is b. Okay, so we get m equals -1 over 1, b equals -1. So now what I'm going to do is I'm going to begin at -1, because I always begin at b. So I'm going to begin down -1. And then here I'm going to do the movement from b. So where I begin, I'm going to do the movement. The movement tells me to go down 1 over 1. So down 1 over 1. Down 1 over 1. Down 1 over 1. Okay, and we're going to keep it going all the way. And hopefully here's kind of the dead giveaway, okay, because I know my lines aren't straight, but we should notice, boom, the m here is -1 over 1. The m here is -1 over 1. So those lines are parallel. So now this tells me, oh, this is a no solution, because my lines never cross. Okay, so now we're going to move on. I'm going to jump on to this problem right here. This one's going to take me a little bit longer. I'm going to do this in blue so you guys can see it. So I'm going to rewrite it as 3x minus y equals -4. I realize that the y is not by itself, so I need to get the y by itself. So I'm going to circle the y, anything attached, make sure you include that negative, okay? That tells me I need to get rid of the 3x. It's a positive 3x, so the opposite is to subtract 3x. So I'm going to subtract 3x to both sides. These cancel out. I'm left with -y. Make sure I will come in here and put a 1 just so I don't get lost. And then here, remember, I cannot combine these. These are not like terms, so I'm going to move the x out in front to keep it in my form, y equals mx, and then b. And then last but not least, you should hopefully realize that that y is still not by itself. I have that -1. So now I need to detach that -1 by dividing. So I'm going to divide each and everything by -1. These will cancel out to give me my y. A negative over a negative is a positive. We can leave it as 3/1, okay, because I want it as a fraction. And then this one, negative over a negative, is a positive. Don't leave this as 4/1 because we never really want b as a fraction. It makes things harder. So 4/1 is going to be 4. Okay, so now I do have it in the form y equals mx plus b. So the m value is 3/1. The b value is going to be 4. So now I'm going to come to my graph. I'm going to begin at b. Remember, b is always up or down. So I'm going to begin up 4. And then I'm going to do the slope, which is up 3. 1, 2, 3/1. Okay, and then just because I'm using most of it and only have these 2 points and it goes off, I will work my way backwards. So instead of going up and to the right, I'm now going to go down and to the left. So I'm going to go down 3/1, down 3/1. You don't have to do this. I just do this so that I can make sure that my line is as straight as possible, especially since I'm not using a ruler. Okay, now last but not least, we need to get this into y equals mx plus b form. So I am going to solve for y. Circle y and anything attached. That tells me I have to get rid of this 1x. So I'm going to subtract 1x to both sides. These are going to cross out. I'm left with 2y equals -1x plus 6. Then from here, I'm going to detach this 2 because I got to get the y by itself. So I'm going to detach it by dividing. So I'm going to divide everything by 2. These cancel out. I'm left with y equals -1/2. Leave it as a fraction. We're good with that. Plus, try not to leave this as a fraction. 6 divided by 2, oh, that's 3. So now the y is by itself. So now, since y is by itself, I know that the number in front of x is -1/2. So that's my movement. And then the b value is the number by itself. So that's 3. So I am going to begin up 3. 1, 2, 3. Okay. And then I am going to go down 1 over 2. Okay, and then I'm going to go down 1 over 2. Let me double check to make sure that I did everything correctly. Let me make sure I copied down the problem correctly. Oh, that's where I made my mistake. Sorry, guys. I do make mistakes at times, especially in the computer, and I don't want to have to go make a whole new video because of this. This right here, my fault. When I copied it down, I didn't copy it down correctly. It should have been a -6. That's my fault. And I knew something was off because obviously I'm not going to get a nice answer. So I knew something was off. So I apologize for that, guys. It should have been a -3. So now I'm going to begin at -3, and then I'm going to go down 1 over 2. Down 1 over 2. That'll make things a little bit easier. And then remember, instead of going down 1, we can go up 1 and to the left. Boom. And that's why I do the points. So now we know, okay, that's where it's going to intersect. Okay, I apologize for that mistake, guys. I really do. Hopefully, you guys understand that. Okay, so now the solution here, all we're doing is figuring out how do I get the x and y. So I go to the left 2. So left means that it's negative, and then I go down 2, which makes that negative as well. Okay, so my solution there is -2.